Today I'm going to teach you how to find the solution to a system of equations by graphing. Now here's the deal. If you don't know how to graph slope-intercept form and standard form, you might need to go back and do that before you start on this task. Just as a reminder, the solution to a system of equations is what x and y equal to make both those equations true. And we take that x and y and we put them in an ordered pair. When you're given two equations and you graph them, the solution is where the two lines cross. And so in this case, right here is where they cross, which looks like that is at -5, 4. That would be the solution to that particular system of equations. So let's get graphing. All right, the first equation is y equals 4x plus 5. So remember, we always start with the y-intercept. In this case, is 5. The slope of 4 just means I'm going up 4 over 1. But here's the deal. When I have students graphing, especially on paper, I want more dots than this so we can really make sure we have a straight line. Because if your lines start to go wacky, you're not going to find the exact spot where they should meet. So I'm going to go down 4 over 1 a couple times here. Okay, and then right here. All right, time to make my line. Okay, there you go. Now let's do the next one. Let's see, that starts at a 1. And then it's up 2 over 1 for my slope. You notice I'm getting further away going this way. So I'm gonna go backwards. So down 2, backwards 1, down 2, backwards 1. And that's fantastic news because you see, I already know where they're gonna meet. All right, let's make that line. All right, where do they cross? It looks like at the -2, -3. Well, how could I check myself? Well, could just put those back into the equations and see if they work. Like the first one, does -3 equal 4 times -2 plus 5? 4 times -2 is -8 plus 5. Yeah, that's -3. And if I put it in the next one, that's going to work also. So yay. All right, another one. Where do I start on the first one? Well, I start at the 4. And then what's my slope? 1. And so I'm just going up 1 over 1, up 1 over 1. But I'm going to go this way also just to make sure that I have a really straight line. All right, let me make that line. Okay, next one. Oh, that is not in slope-intercept form. That's in standard form. Do you remember how to graph standard form? Some people will convert it into slope-intercept form, and some people will use the cover-up method. Now I'm going to use the cover-up method, but I'm going to be kind of scribbly about it. So if I just cut that one out right there, and I have 6x equals -6, what would x equal? What times 6 equals -6? Well, -1. So my x is -1. You remember doing that? Alrighty. And then I'm going to do the same thing. I'm going to just scribble this out. And I'll say 3 times what equals -6. So 3 times what is equal to 6? -2. So y equals -2 right here. And I could do my line, but again, remember how I said that the line will get kind of wacky if I don't have more points. So I'm going to look at this and I'm going to say, hey, look at that. I see that the slope is a -2, down 2 over 1. I can do it again, down 2 over 1, or I can go backwards, up 2 over 1. Oh, that's great because it's going to go right there. Now I know what my solution is. Let me draw my line. So what is the solution? Where do the two lines cross? It looks like it crosses at -2, +2. And again, if you don't trust that, put them back into the equations and see if they work. Here they're both in standard form. But again, I'm just going to use the cover-up method. And so I'm just going to cover this up. And what does x equal? -2. So I'm going to go ahead and put it out there. And then erase that. And do the other one. All right, y equals what? -2. So there we go. You can go ahead and draw your line, or you can look at it and say, okay, what is this slope? Actually, the slope down 2 over 2, so downward over 1. So basically, I can just do this. And again, all I'm doing is making myself some more points. If you're doing this on a computer, you don't really need to do that. If you're doing this on paper, you absolutely should. Okay, here we go with the next one. I'll hide that. 2 times what is -2? That would be a -1, so x equals -1. And do the same thing on the other side. 2 times what is -2? -1. So right here is my x value. Okay, let's continue this slope a little bit. So it looks like it's just down 1 over 1, down 1 over 1. Wait a minute, isn't that the slope we just had on the other one? In fact, what do you notice here? These two lines are never going to cross. When you have two parallel lines, two lines that are never going to cross, then there are no numbers that will make x and y true in both of those equations. They're never going to cross. And so the answer to this is just no solution. Anytime you get parallel lines, your answer is always going to be no solution. I have one more example to try, so let's go for it. The first one, my starting point is -6, so right here. And my slope is 3. So up 3 over 1, up 3 over 1, up 3 over 1. Let me go backwards 3 over 1 because I don't know where the other one's going to cross. And let's make our line. Okay, let's do the next one. I'm going to hide this. -6 times what is -12? That's a +2. So, oh, hey, look, maybe we just found our solution. But let's keep graphing. So the next one, I'm going to hide this right here. And it says 2 times what is -12? Well, 2 times -6. Uh-oh. Huh. If I were to connect those dots, what do I have? I have the exact same line. Let me finish graphing. So what do you call it when every single number on the line is going to make both of those true? Well, it's not all real solutions or all real numbers. That would mean that everything on the entire grid would make it true. The correct phrase is infinitely many solutions. All right, that's it. I've given you the two specials that will happen. It's now your turn to go graph and find some solutions. Go have some fun.